Okay, good morning, everyone. I'm Riccardo Di Marino, and today, during this seminar, I will present to you a solution based on infrastructure self-provisioning tool, which is used to speed up the cloud adoption by enterprises that are going to approach the cloud. The webinar will close a few topics, but I hope interesting topics, including the adoption of the cloud, as said, by enterprises. Why do they opt for a cloud adoption? They want to enhance their business value, basically. And also, they want to use migration strategies to address the best possible approach to arrive to the cloud. Then I will present you a customer story at a very high level. Okay, I will put in evidence the scenario and the requirements with the aim to provide to customer a tailored solution, basically, which is capable and able to accommodate also the future improvements, so that it can evolve with the customer growth, basically. Before getting into the details of our solution, of the deployed solution, I will travel across the, let's say, the cloud paradigms and cloud services that are at the base of this solution. And they are the service catalog at first, and then the infrastructure as code, but also the serverless. And then I will move through the description of the architecture framework, showing the main components and their relations inside this environment. The final part, instead, will be devoted to a short hands-on session. Very short, could be divided in 2 or 3 parts, let's say, and I will inspect there the key aspects of the deployed solution, and then some conclusive considerations obviously will be drawn. Okay, just some personal info about myself, and to let you aware of who am I and of my background and my personal work area. Okay, I am Riccardo, and I am a reply consultant. I'm a former student of Politecnico di Torino, and I got my master's degree in telecommunication engineering in 2019. Then I worked for 2 years in another consultant company, and then I joined Reply for a new adventure in January 2022. This adventure let me work, but also study simultaneously, and this allowed me to pursue the second level specialized master in artificial intelligence. This was the second edition. Actually, I'm a part of Storm Reply, which is a reply company focused on delivering solution based on Amazon Web Services, or also called AWS. It is specialized mainly on approaching the enterprises to the cloud and also applying an effective digital transformation to them. Okay, but I don't want to lose additional time, so I start with the cloud adoption. Few words. The adoption of the cloud, basically, it is and has become a crucial point for most of the companies, especially the one that deliver digital services. Indeed, the market and its ultra-competitive environment requires a proactive approach in delivering solution, in continuously develop and release new digital services in the market, and this release has to be well interconnected with the agility of the business processes. In this sense, the companies with great experience in cloud processes, such as Reply, play an important role in this, and they have to ensure their customers can perform an effective cloud adoption. So Reply has a framework proposed to its customer, a specific framework which is named CAFFE, Cloud Adoption Framework for Enterprise, which relies on basically 4 pillars. First of all, the definition of cloud operating model. So it consists basically in stating who is responsible for what. And it defines the company governance and address the specific set of function to particular teams. And also it defines the relative cloud processes. The second aspect is the design of the organization. It is really important that an organization that moves into cloud can be identifiable. The cloud is very large. In a cloud provider could be a lot of organization. So it is important to define in a good way the organizational structure, as well as the definition of the roles, and also the responsibility and the skills that are distributed inside the organization. Therefore, to enable the delivery of the services from the cloud, the companies need a so-called landing zone. This is a critical component, and it grows basically all the services of the cloud. Building a landing zone is not easy, it's not immediate, let's say, and involves both technical but also technical decisions. They are performed in different aspects, so from the account structure, but also from networking and security. Think also about the market in which you want to put your production. This is quite important. And finally, a tool chain has to be set up. Basically, a tool chain is a set of tools which come together to deploy, change, and also tear down the services in the cloud, obviously with full automation. Let's say that for an effective cloud adoption, sooner or later the companies have to migrate their application to the cloud. And in order to do this, I show you these 7 R's strategies, but I don't want to go into the details. Just take in mind that it is important to preserve the capability of the customer to be able to provide value and to build value also whenever it lands to the cloud. And this is something that is not easy to achieve in a short time. So provide business continuity is quite fundamental. So if a company makes shoes, it is not interested in how things work. You want to continue to produce shoes also in the market. So in this sense, let's say that as cloud engineer and the cloud architect, I'm responsible, and you are responsible, let's say, for the design and the implementation of solutions, which are no more than a balance in between the customer requirements and the vast plethora of services that are available to you and that are provided by the cloud, in the specific by the cloud provider that you choose. In this solution, it will be AWS, so Amazon. There is not an optimal solution, but you can, with experience, you can acquire the capabilities and the ability to refine the addressing of the problems with specific services and not others. And so it's quite a challenge to get this. Okay, I want now to spend a few words about the description of the customer stories, which led us to the deployment of the solution. In particular, what the customer asked us. They want a self-service portal, which acts as a front end, basically, which is entitled to deliver and perform the provisioning of the cloud infrastructure. And for cloud infrastructure, I mean, basically whatever kind of resources in the cloud. So it could be a compute instance, a database instance, an object storage system, whatever, a network components, whatever. Then every product, and this is a quite important point, has to be standardized. So they have to follow a predefined standard. Imagine you are in a big company with big teams, and those teams have to follow rules in order to be consistent with others and perform and put the product in production. And so standards are really necessary. And then they want to find a way to address in an effective way the cost of the resources. They don't want to lose their money. They don't want to spend much more than required. Okay, the context in which we have to work is a multi-account scenario, as you can see. So there's the development, the testing, and also the production and environment. And the AWS account were new, basically. And so there aren't no resources deployed yet in any environments. And this led us to design our solution from scratch, basically. The major challenges that were given, that we have to face, were given by the deep understanding of the basic configuration of these cloud resources, this cloud infrastructure. They have to apply configuration on them. And then we have also to balance in between the amount of instruction that we have to put when the customer asks for resources and the time to have that resource ready to be used. Then we need also to automatize the end-to-end process. So with a click, we have to let the customer to have the product, the final product ready to be used. And we have to adapt dynamically to the service requests. Service requests are affected by some configuration stuff, but also parameterized stuff, because the users can apply its parameter to specific product. And this can be solved thanks to the conjunction and the potentialities of the serverless and the infrastructure as a code. We provide about the solution. We brought to the customer a cloud-native solution, which is based on service catalog, and we leverage on the serverless potentialities in conjunction with the infrastructure as code, as we will see later. We opted then for a configuration management tool, which is able to facilitate the configuration, the maintenance of the product. Okay, but now the clients interrogate itself and say, okay, but how can I be fast now to bring my to deliver my digital service to my teams, to my internal teams, and also I want to increment my business in this sense. And the answer is try to adopt a cloud service cloud catalog. Definitely, we answered in this way, which offer a solution capable to centrally manage all the service requests that are performed by the users. We decided in particular to opt for a cloud service approach, which is cloud native. And this to make more flexible and independent the development of the entire architecture. We also improved the service discoverability, and we can count on software compliance in accordance with negligible license costs, because we do not have to pay any license in this kind of solution. We can count also in a full compatibility, because with the entire ecosystem, with the entire cloud ecosystem, and the delivery process or the time to value is speed up through pre-approved cloud architecture patterns. The drawbacks in this kind of solution can be a possible service limitation, because it could be possible, for example, a network failure, a DNS failure, and so during this time, the service is not available. But the products that are behind it continues to are still they still remain. So in this sense, it is not a lack of services. There is not a lack of service. It could be possible also a lack of agility during the transformation of the company and of the business, because if a product is too much standardized, it is difficult that it can provide additional value. So as we said, we can count on central management. So we have a single portal for the requests, and we have a view of all the active services, and also we speed up the operations a lot because we automated our process. And we brings products in minutes, reducing the time spent to request for them. Then we also optimize the cost through tag. Basically, we tag every resource with a specific name, and we also predefine the workloads, and we were able to coordinate and fulfill every kind of service request in this way. The services provided by AWS is called AWS Service Catalog. I don't want to spend much time on this, just let you slide. And but I put here the main features, which are the products that are the main piece, the basic brick of the catalog, and basically they are created through a so-called template, but a template in the specific an AWS CloudFormation template. AWS CloudFormation is the service that performs infrastructure as a code in AWS. Then we can manage multiple versions of the products. Indeed, we can create the version is enabled for the products. So we can create multiple versions, and automatically they are inherited by the product. So you can quickly update your existing application or downgrade it if you need it. An important concept is the portfolio, because the portfolio is the collection of products, and the portfolios help the management of these products, and it is possible to share it with particular teams, but not with others. And in this way, we can address the development products to the development team, the business product to the business team, and the network products to the network team, for example. And then we define from the other side, from the user's perspective, also the access to that product through the IAM paradigm, which is the identity and access management paradigm, which state permissions to control who can view the portfolios and the products that are inside the portfolio. So, long story short, we basically are able to centrally manage the deployed IT services, achieving consistent governance through the infrastructure as a code template, through the use of the infrastructure as a code template, but also we meet the compliance requirements while ensuring the customers can deploy only the approved services. So these products are pre-approved in such way before to be delivered. Okay, now let's proceed to an important feature, which is the infrastructure as a code that I mentioned before. I don't want to spend much time on this, but it is important to understand that if in the past the setup and the configuration of the physical server, especially in on-prem environments, was mainly managed manually, nowadays it has become possible to, let's say, treat the infrastructure as it was code, and this automated the provisioning process and the entire deployment process. And basically, when you perform manually those kind of operation, you put yourself at risk, and the risks are basically that there is no version control, there is a management of your data which is inconsistent, and you cannot scale because you have to apply manually, resource by resource, your change. And also it is track the operations became a nightmare. Indeed, through the automatic way, it is possible to define a single template file in which all the deployment is described, and you have a consistent architecture in this way. The infrastructure as a code tool for AWS is the AWS CloudFormation. Basically, you can report here a picture from the website, and you can code your infrastructure through a template file, through a CloudFormation template file, which is written in YAML or JSON. And you can put this template file wherever you want, so locally or in an object storage system, which in Amazon is called S3 bucket. And then you can launch the CloudFormation template through the browser, through the command line, or through API. And basically what happened, it is created a stack which is based on what is written in your template code and contains all the information relative to the state of your deployment. And then you can define also the outputs. Outputs are important. Then we will see, for example, they can contain the IP addresses of our resources, for example. Okay, now let's move on serverless concept. The serverless basically introduce an additional layer of abstraction from the application development point of view, because as the word suggests, you don't have to worry about the management of the underlying infrastructure of the server. But the question is still valid, because is there any server eventually? And the answer is yes, it is present, but it is in cloud, and you will pay for it, but in a different way, with under a different cost model. Serverless is quite used to develop an event-driven based models. And as we will see, it is the backbone of our solution. Event-driven model where an on-demand request can trigger an event, and through this event, the resources are allocated, then the snippet of code is executed, and then after this execution, the resources are released. So basically, the serverless allow us to improve the agility in the development, because definitely we write less code and we are focused on our business logic, only that, to provide value to our company. We boost the performance because the underlying infrastructure evolved technologically with the cloud. And things about the RAM, the CPU, and the storage technologies that will arrive in the future, we inherit them through the serverless, because we run our function in some way. And if the technology is advanced, also the execution can benefit of it. The cost model has changed, and it becomes a pay-per-request model. And also the security is enhanced, because you define who can use who can call the function, so you can use these services through roles and access. And you can also count on resiliency, because the execution are isolated from the entire solution. So if something of wrong happened there, it remains there. Other function can be triggered, and execution can go. Okay, the main serverless service is the AWS Lambda. Basically, I try to recap in a few points. You can bring your code because you have full compatibility with any sort of languages, of programming languages. You can have Java, PowerShell, Node, JS, C#, Python, and Ruby. And also, you definitely write less code, as said, and you can focus on your business logic. The resource, you don't have to take care of the resource, but you size, let's say, your execution basically on a single execution. So if you perform one request, it is the same if you perform 100 or million of requests. The cloud providers guarantee you that the execution time will remain the same, and it will remain the same, of course. because you pay for this service. So we can say that the execution time is decoupled from the workload, so from the number of requests that are incoming to this service. We have fully compatibility with the AWS ecosystem, because the Lambda function can be triggered by whatever events coming from whatever service in the cloud, in the AWS cloud. And the service is secure by nature. It applies the least privileged paradigm, for which no access is provided if not well-defined granularly with access, with explicit access rules. Okay, the model is a pay-per-request model, and the cost is strictly related to the business model, because many users can trigger many requests, and those requests cause more business, but also much more expenses. But it is also true that vice versa, because if you have no user, no requests were made, and no execution were done, so you don't pay basically. And this define a true allow us to pay for the true IT cost. And also, obviously, the maintenance is quite limited, because evolving your application, you don't have to worry about the underlying architecture, but only on change something in your code. Okay, let's move on now on the architecture framework. So basically, on our solution, it is quite simple, but I want to show you that it is basically composed by a front end, okay, which is in the left side, and the front end contains the AWS service catalog and a back end, in which instead are performed all the provisioning stuff and configuration stuff in order to deliver the final product selected by the user to the user. Okay, for what concerns the front end, I said it is fully composed by the AWS service catalog, and the service catalog exposes to the users a portfolio and its relative products. The offering can be subdivided into, so we have two types of offering: the infrastructure as a service provisioning, and platform as a service provisioning. The first one is made through the EC2, which corresponds to the compute instance in AWS. They are virtual machine, basically. And the S3, which is an object storage system, an object storage service. Instead, the platform as a service is identified by the RDS, which is the relational database system. In our solution, the portfolio is called provisioning, and a product, as I said, is described through the CloudFormation template that contains all the information and all the resources, but also the set of parameters that the users will insert on it to, let's say, customize it. And at the end of this step, we have a parameterized product, which will be the input of our backend. The parameterized product is nothing more than a combination of AWS CloudFormation template and parameters. And here is there is from the automation point of view, a point of discontinuity, because we cannot know in advance what will be the parameters that the user will insert. For example, how many resources in its deploy he wants, and also where to put in the network those resources. For this reason, what happened? It will happen that the CloudFormation, the AWS CloudFormation, grabs information from the information in this combination, template and parameters, and triggers the Lambda function. It will trigger the Lambda function through a well-defined features that we will inspect later on during the hands-on session. The Lambda, basically, which is the serverless side, processes the template and remanipulates it. And then it returns back to the CloudFormation engine, which can proceed with the processing of the final template in order to deploy and release the cloud native services and configure them. Okay, at this stage, the user can have requested for an RDS, so a relational database system, which is fully managed by nature, by AWS, and it is directly delivered. Or it can have requested for a compute instance, so a virtual machine, and in this case, the compute instance is equipped with a specific software image built with Packer, which is a software, an image builder tool that creates the so-called golden image. And this golden image have to be configured then. And we decide to configure them through the configuration management tool, which is Ansible, that grabs software from an object storage and applies this and installs software. It performs something related also to the networking. It applies a host name to our compute instance, and then it releases and delivers to the final user the compute instance. Okay, the configuration management is Ansible, few words. Basically, the configuration management has to keep consistent the system setup and the settings of the system. During this step, and using the configuration management, it is possible to perform the so-called hardening, which is something that is much more, it is a complex concept, but basically you took care of install the only necessary software, and this lets you to be to not expose yourself at vulnerabilities, basically. With Ansible, it is possible. We choose Ansible because it is easy to maintain, and the action to perform are configured by tasks. Basically, tasks are a standard, are well defined, standard written in a well defined way, and they are grabbed inside playbooks. And playbooks are the list of tasks that are executed sequentially to configure your instance, your resource. Okay. I finish here the, let's say, the most theoretical part, and I want to, if it is possible, okay, maybe it's. I want to pass to the demo session, in which we will see very quickly the what is behind our solution. So basically, I want to start from the AWS Service Catalog product. This is the AWS console, first of all, and here we are in the Service Catalog product. As you can see, there are two sides. It starts from the administration and the provisioning. The administration is the side that allows you to define your product. You can create your product by clicking here, and the product basically is can contain these details. So the product name, a little description, the owner, and the distributor. But the distributor. But I want to point your attention here. When you have to create a product, basically you have to select a template file, which can be in a local folder or in a S3 template viewer, but it could also be recovered from an existing stack. The stack is the description of the deployed architecture, and obviously it contains a template. then you can insert all the details of your product version. Another important thing is that your service has to be identifiable inside the service catalog. So you put here your team's, let's say, information or your personal information in order to be reached if any users need to ask you something. Okay. This is how it is possible to create product. Okay, just wait what happened. Okay, then I want to move on the portfolio section. Here, as you can see, we have the portfolios, the list of portfolios available. The one that we have is the provisioning. And inside the provisioning portfolio, if you click here, it is possible to basically assign the relative products. In this case, we have 9 products, and they are EC2, so compute instance, and RDS, so relational database instance, with MySQL, Postgres, and others. It's not important. And you can also share your portfolios with the internal organizational unit in order to make this portfolio available to your target users. Okay, I want now to show you how it is done a product and how it is defined product, and basically this is the template that describes an EC2 instance with a web server, which acts as a web server with Apache. The AWS Cloud Formation template contains the template format version first. It is defined in YAML, sorry, and a brief description. And then, not always, but in this case, it is useful for us. It contains the transform. The transform is that features that will trigger our serverless function, our Lambda, basically. So it let the Lambda to take let's say, pause the engine of the infrastructure as a code, pass to the Lambda, and wait for the Lambda get back this, come back with the process template, and then it can process. An AWS Cloud Formation template is composed by these building blocks, which are parameters, metadata, mapping condition, resources, and the outputs. And for the standard products of Apache, of the Apache instance, we have defined, for example, an EC2 instance. Then user apply parameters and can, for example, ask for 2 instances. And so this template has to be manipulated in some way. Okay, I want now to change the account. So sorry, these are confidential information. I want to change only the account, and then I come back to you. Okay, so now to provision a real product, I became basically a developer, and through the provisioning side, I can select for a product. And in this case, I want to, for example, I want to show you how to provision an Apache instance, in the specific 2 instances, and we will see. And when we click on the launch product, we can enter a provision product name, and I will insert the Crown Labs demo, for example, the relative version, which is available to the user. And then you have to apply parameters. Those parameters are the same, and this is a graphical translation of our template that I show you here. If I click here on parameters, I can see that in the instance type, I have allowed values. And those are this. And I can find basically them here. If I click here, they are the same. So it is the graphical translation of the template in where I apply my parameters. Okay, I want to create resources in a particular side of the network. So this is not important is out of scope of this session, but just to allow the process to end. And then here I can select my operating system version. I have two deployed, and they are linked to the golden image. A golden image with this less operating system, less 15 operating system service pack 4, and a golden image with a less operating system 12 service pack 5. I opt for this, and I want to deploy two resources. Obviously, I have to set the two host name. And the host name for this team could be hello Ground Labs, and Ground Labs is cool, for example. Okay, then I move on, and here I put tag. Also, tags are not important for this, but they are useful to address the cost to the correct team. So don't care of this. Here I can put test. And then finally, once configured, I can launch my product, which consists basically of which will consist of two EC2 instances with an Apache server installed on it. Okay, I click on launch, and then I arrived on this page, which is the provisioning product. So basically, my product has been deployed. So Ground Labs demo is this one. Okay, and it is possible to see inside it some details. In particular, the list of resources that are going to create, which are going to be created, and we can see that the resources are, the creation is in progress, but also we can rely on the stack address, which is here, in order to see that all the data, all the parameters inserted are correctly recognized by the system. So I move on the CloudFormation service, which is the infrastructure as a code tool, as I said before. And I want to show you that if we see here we have the events. So what is happening till now? The list of the resources it said, but I want to show you that the parameters are correctly ingested in the system. So it is 2, and you have also the host name correctly defined. So we will see later in the outputs the IP, but now it is yet in creation, because if you see the event, sorry, okay, the resource creation is initiated. I want to show you the template tab, and in particular in this view there is the template provided, the standard template of the Apache of an Apache instance that I already showed you, and in this side we have instead the template with the parameters details to apply to each resource. I want to copy this on clipboard, and I want to show you that if I want to beautify it, maybe sorry, beautify, I don't know. Okay, and show you in the notepad. Yes. How it is done. So basically, okay. Basically, what happened? So what the CloudFormation engine received back from the Lambda. It received back from the Lambda this template, in which it is basically the same, but it contains no more one resources but 2. And those are the two EC2 instances. And then also it was able to, the Lambda function was able also to replicate the set of outputs. So we have two private IP address, two SSD and two hostname, which corresponds to the name that we set on that instance. Okay, I think that in the meanwhile that I talk, the creation has been concluded. Oh, okay, and we can see from this view, but also from the provisioned products view, which at the end, Crown Labs demo, the products is already and it is available to the user. So let's try to access. Let's try to access, and we can investigate on the basically the outputs of our products. And in the output, we have the private IP address one, and as you can see, if I put, I'm in this is the private IP, okay, because I'm connected in an internal network, so I can react it. Obviously, you cannot if you are outside this network. And this is the first instance, so the Hello Crown Labs instance. We can also react the other. Oops, selecting the other IP. Okay. Okay, and this is instead the Crown Labs school instance. We also can also connect through SSH inside them, and I want to show you that the service is up and running. But I have to, for example, I want to connect to this. I have to copy the IP, pass here. Okay, just a moment. Okay, let's add in the now host. And here we are. Okay. Okay. This is my instance, which is the Crown Labs school instance. And if I run the sudo system ctl status of the HTTPD, which is the Apache. Okay, I forgot an S. HTTPD service, the Apache service. Okay, I can see that my service is up and running. I can also curl my localhost in order to see that the page is the same, the index page of my virtual host. Okay, basically this conclude, and this is a process that is possible to apply also on the other instance. This basically concludes the first part of the hands-on. I have other 10 minutes, and I want to show you in 10 minutes the second part, which which instead exploit and explore the serverless potentiality. Okay, so basically how the template has been manipulated. So what is the logic behind the fact that from one instance they became two, or they become more in the final template? And in order to show you this, okay, I have to move in the AWS Lambda service, but the function is contained in the administration account. So I move on the administrative side. Okay, and I'm looking for the AWS Lambda service. Okay. Perfect. And here I am inside my Lambda function. Basically, below is defined the code. As you can see, is in Python, but I really love Notepad, so I show the code of my Lambda from this, just to let you know that what are the main routines that are triggered by the Lambda. The first one is the handler, which receive an event, and we will see what is an event. Basically, what happens inside. I print the event in order to show you what is this event, and you can see that it is it contains the fragment and the template parameter values, and in the fragment it is define the predefined template, the predefined AWS CloudFormation template, while in the template parameter values are inserted the parameters value of the user. And then I will show you in the log, printing in the log, the final template. Basically, the process template routine will execute other three subroutines. The most important are these: the set MEI, in which the operating system, the parameter of the operating system, will call the corresponding golden image with that operating system, and then also the network placement of the resources inside our network, and it is done through this routine. Okay. Good. So I wanted to show you two important features, which are the monitor. The first is the monitor features of the Lambda, and we can see the logs, all the logs in another AWS service, which is the CloudWatch service. Basically, this service is able to group the logs and also organize the group of logs in streams. So let's see if the log of our previous execution arrived in the stream, and let's inspect them. If not, I've ready for you a different approach. Okay, let's say that possibly this could be the right streams. So we investigate on this, and we expect to find on it the events. If the console today is very slow. Okay, just a few seconds. Okay, here we are. As we can see from the start, which is our context, that could correspond to this, we have the event. And the event, I want to beautify this event. So I go here on the post. The event, as said, are contained all the information of the. Oops, this is sorry. Okay, let's see from the. Okay, it's contained the fragment, which contains the original. Let's see from here, the original template, the standardized template, but also the parameters inputted by the users. And in this case, we have two resources. So what I want to do is try to copy this and modify it. Let's see if it will be possible. Okay. I don't know what happened. Okay, so in the template parameters value, I want to change this, for example, in 3, and I want to add another host name, which is I don't know. Okay, we are Crown Labs. Okay. Then copy it, and I want to show you the second features, which is the test, because we can also test our Lambda function, creating a so-called event. So, and I put my code here. I save this event, and I prepare it to be tested. Okay, there is a syntax error. Obviously is inside the host name because there is a comma. Okay. So I save the changes now. Okay. Well, it's good, and then I can test my function. Okay, as you can see, the result succeeded. I copy this code, and again, I paste here, and then I fold all the code in order to see that in the fragment, which contains the updated template, there are now no more than 2 instances, but 3. We have also the third one. And also the set of output are multiplied. And you can see that the third host name becomes Crown Labs. Obviously, this is a test, so we do not have deployed really, but I want to show you how the serverless works on this process. Okay, basically this ends with this I conclude I conclude my presentation, my demo, and I'm going to explain and say something in conclusion. Okay. Thanks to this solution, so we have highlighted the potentialities of the end-to-end service. Of the infrastructure as a code and the serverless that work together, exploiting their cooperation to fully automatize the end-to-end process. We also enhance the excellent application of this kind of solution in multi-account organization, and we demonstrate that with extremely ease, it is possible to deliver the final product to the users with very few in cloud infrastructure. The so-called time to market is drastically decreased. So from days, imagine that you have to send email to perform your service request in a big environment, and then pass days and days to this to resolve this your service request. In this way, in few clicks and very few minutes, if not seconds, it is possible to get the final product. And then we have standardized at all our service delivery with the standardized AWS CloudFormation template. And also, we make the internal provisioning process definitely more dynamic. Obviously, all this is done also for in order to optimize as much as possible the cost. Okay, thank you for your attention. Thank you, and I wish you the best for your exam. And also I would like Professor Fulvio Risso allowing this presentation to be included in the review of the Crown Labs seminar. Thank you. If you have a question, you can ask me now, or I also leave here my email if you want to reach me out in a second moment.